Imagine you are sitting at your computer, about to launch your favorite game or train a new artificial intelligence model. Have you ever wondered what is really happening inside your machine? Today, we are diving into the world of computer processors and graphics cards. You clicked on this video because you want to know the real difference between a CPU and a GPU. And by the end, you will see how this knowledge can change the way you think about technology. Let us start with the basics. The CPU, or Central Processing Unit, is often called the brain of the computer. It is designed to handle complex tasks, one step at a time. Think of a CPU as a master craftsman. This craftsman is highly skilled and can solve difficult problems, but can only focus on one or a few things at once. If you have a single-core CPU, it is like having one craftsman. Add more cores, and you have a small team, each working on a separate complex task. An 8-core CPU can handle 8 complex jobs at the same time, but each job still gets the full attention of a skilled worker. Now, let us talk about the GPU, or Graphics Processing Unit. The GPU is like a huge team of workers, each with a simple job. Imagine a factory floor with hundreds or even thousands of people, each doing a small, repetitive task. Individually, they are not as skilled as the master craftsman, but together, they can finish massive projects much faster if the work can be split into many small pieces. This is why GPUs are so good at rendering graphics for video games, running calculations for artificial intelligence, or processing large amounts of data all at once. Here's a quick question for you. If you had to build a house, would you rather have one expert builder or a whole crew of helpers? The answer depends on the job. For a delicate custom staircase, you want the expert. For painting all the walls, you want the crew. This is exactly how computers use CPUs and GPUs. The CPU takes care of the tricky, decision-heavy parts, while the GPU handles the bulk work that can be done in parallel. But there is a twist. As technology evolves, the line between CPUs and GPUs is starting to blur. Some modern CPUs are getting more cores, and GPUs are becoming more flexible. This creates a subplot in our story. Will there come a time when one chip can do it all? For now, each has its strengths, but the race is on. Let us break down the main differences into 3 key points. First, CPUs are optimized for versatility and complex logic, while GPUs are optimized for speed and parallelism. Second, CPUs usually have a few powerful cores, and GPUs have hundreds or thousands of simpler cores. Third, CPUs excel at running operating systems and general applications, while GPUs shine in graphics, machine learning, and scientific computing. Here is a real-world example. When you play a video game, the CPU controls the game logic, like keeping score and handling user input. The GPU draws the graphics, rendering every frame you see. In artificial intelligence, the CPU sets up the problem, but the GPU does the heavy lifting, crunching numbers for training and inference. So, what is the most valuable insight? Understanding the difference between CPUs and GPUs can help you make better decisions, whether you are building a computer, choosing cloud resources, or just curious about how your favorite apps work. The next time you hear about a breakthrough in artificial intelligence or see stunning graphics in a new game, you will know which part of the computer made it possible. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.